Hi everybody. In this video, we are going to do an example that you are supposed to do on your own and use that to evaluate yourself. Everything is really easy and you could, of course I could do that. Oh yeah, I get it, when you watch someone else do it. But did you try it on your own? Or are you still watching this and saying, yeah, I understand. Psh, no big deal. Just wait and see what happens if you have a test or quiz. So if you didn't try it on your own, press pause if you stumble upon this video, try it on your own and come back and see how you did. But let's get going. First thing I notice is I have a cosine equation that I'm trying to graph. Not only is this cosine, but it is positive cosine. So I need to recognize what the shape is going to be. If you know the cosine parent function, you use the tick marks of the quadrantal angles, 0, pi over 2, pi, 3 pi over 2, and 2 pi to kind of check in with your cosine values and get that shape. Cosine at 0 is 1, then we get 0, -1, 0, and 1 again. This middle part is concave up, looks like a cup, and the two sides are concave down, looks like a frown, arrows at the end because it goes on forever and ever. So that is the positive cosine graph, parent function. And just so we have a side-by-side comparison, negative cosine really is the same parent function, but with a vertical reflection. So the only difference is it's going to be a bit more like this, and then this part here, concave down, looks like a frown, and the two ends are the little concave ups, and that's going to be the shape. In either case, you will have 5 tick marks, 1, 2, 3, 4, and 5, just like that. So we have positive cosine, so we are going to use this shape. So what I'm going to put a little plus sign, we don't really need that, but just so I'm acknowledging that is being addressed. So what I'm going to do is I'm just going to draw a bigger version of this. So I'm addressing the fact that it's positive, and I'm addressing the fact that it's cosine. I'm going to draw that out. So let's do that. 1, 2, 3, 4, 5. Now, if you watch the video of the guided example, I feel like I put the points a little bit more squished together this way, and it eats up a lot of your space to label. So by stretching it out, you're just giving yourself more room, which is nice. Okay, next thing that I like to do, and I'm trying to use the same colors, but we'll see what happens, is I'm going to deal with this 6.5. That's the K, and that took the whole entire graph. It's all holding on to this dotted sinusoidal axis. It's like, hey, I'm holding on. Where is it holding on? Right here. If a cosine graph had hands, they'd be right there at those spots. This is where it's holding on, okay? So that's where it's holding, and then the whole thing moves up. So I'm going to draw my sinusoidal axis in blue, but drawing it is not enough. Like, we know the number, it's 6.5. So let's label a 6.5 along these dotted lines. In fact, it's an equation of a sinusoidal axis. So I'm going to make it an equation, y equals 6.5. Lovely. Next thing I am going to address in orange is the amplitude. Amplitude is positive, and it's positive 3. We're going to see that amplitude here. We're going to see it right there, and we're going to see it right there, as long as also in every other wave that continues along this graph. All right, that has a measure of 3. Sometimes we go down 3, and sometimes we go up 3, whatever, but the distance of how far the max and min are from the sinusoidal axis, the maximums and minimums, is 3. Now, if that's 6.5, then what is 3 above it? I don't need to write y equals because it's not an equation right now. We're just acknowledging the y value there. It's going to be 9.5. And then what is 3 below? These are just little notes on the side, okay? It's not going to be, what am I doing? 3. So it's not going to be negative 9.5, but it's going to be 3.5. Okay? So 3 apart, 3 apart. So far, so good. Now, the next thing, so I do this, that, B, A, H, no, K, sorry, rewind. K, A, H, B. I guess that's how I go. So, oh, and I could have drawn my graph. I don't know what I'm dilly-dallying for. Got that? Okay. Negative, or x minus 5 pi over 7. So minus on the inside moves our graph 5 pi over 7 to the right. And if you still don't know that, if you're still messing that up, you need to go back and watch some older video and really learn the transformations, because you just got to know it. I can't know it for you. That one I believe I was doing in pink. It's not this point. It's this one. It's the first one. This point, if I started looking at this from here, and it keeps going, I'm looking at a negative sine wave. If I look at it from this point here and go from there, that's a negative cosine wave. If I look at it from there and keep going, that's a positive sine wave. So it depends where you check in. You got to pick the right starting point. You got to do it based on the trig function in front of you. So this right here, 5 pi over 7, and we said it's to the right. So what else could we add in this picture? Well, these are all positive, so my x-axis is somewhere underneath here. So it's like that's 0 for the y value. This is to the right, 5 pi over 7. So I could just stick my y-axis right here. Since I'm going to go to the right of 5 pi over 7, everything will be positive. So my y-axis is already drawn. I could go here, here, and here and put my tick marks, 3.5, 6.5, and 9.5. I'm going to leave a little room, like I did in the last video, I believe. And I'm going to put 5 pi over 7, and I might leave a little room for equals, because we probably have to find a common denominator, right? So you need to leave that room. Then I'm going to have 4 more tick marks. 1, 2, 3, 4. Not so bad. The distance from start to finish is the period. That's how long the period is. I did purple for the period. That's the period. So I will demonstrate that right over here. Okay? Right over there. And that is the whole period. You just need to find the period so that you can find the quarter period. 4 quarters make a whole. So you know how much you're adding to go to the next spot. Okay? So that's what we want to do. So let's do one thing at a time. The formula for the period is 2 pi over b, which is 2 pi over 2, which is pi, or pi over 1. A quarter period is 1/4 of the period. So it's going to be 1/4 of pi, which is pi over 4. If the quarter period is pi over 4 and h is 5 pi over 7, I can't add them the way that they are. So h was 5 pi over 7 and q is pi over 4. What will be my common denom? 7 and 4. Well, it's going to be 28. When you find a common denominator, when I was looking over homeworks, some of you weren't multiplying on top and bottom. You only multiplied on bottom. You're changing it. That's like when we found 1/4 of the period. If you multiply on bottom by 3, then you're finding 1/3 of it. You're not keeping it the same. So watch out for that. So this is going to get multiplied by 4 on top and bottom, and this is going to get a 7, and they'll both have a 28. So h will be 20 pi over 28, and q will be 7 pi over 28. So this will be 20 pi over 28, just rewritten with the common denominator. And all I got to do is add that 7 to the top 4 times in a row. And that's it. You're done. Finished. So 20 plus 7 is 27 pi over 28. 7 more, 34 pi over 28. 7 more, 41 pi. And 7 more, 48 pi over 28. If you want to check if your answer seems good, what you could do, last, which was 48 pi over 28, minus first, which was, I would pick this one with the common denominator, of course, 20 pi over 28. If you subtract that, what do you get? Running out of room. Squeezing. Right over there. I'm going to get 28 pi over, no, not 28. Oh, yes, I am. Psh, silly me. Over 28. Like, why am I writing 28? That's the denominator and the numerator. And 28 reduce, and I get pi. If I do last minus first, I get the period. Was the period pi? Ding, 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 ding. So winner, chicken dinner, you got it. So if you had all of this information on your graph, you're perfect, you rule, go you. If you tried to do the domain and range, if you're curious, the domain, this is a smooth continuous function, no breaks, no interruptions, no discontinuities. So the domain, using interval notation, just goes from negative infinity to positive infinity, or on your side, maybe I'm pointing the other way. And then the range goes from bottom to top. We're talking about y values, bottom to top. So from 3.5 to 9.5, the graph is going to oscillate up and down between those two numbers. They're included, so I use a bracket. 3.5, comma, 9.5. There's your domain and range. There's your graph of a single cycle, a full period of a cosine function with all sorts of transformations applied. If you feel fairly confident about this, like you could get a pretty decent grade if you were given an assessment on this to do on your own, then put a thumbs up on the video. But if you think you're not ready, you're not there yet, and you shouldn't be too confident, then put a thumbs down on the video. Greatly appreciated. Helps me know what you guys need more practice with when you're a little bit more bashful and don't necessarily want to admit it. I don't know who puts the thumbs up or the thumbs down, so I don't know who specifically it is. All I know is how many of each there are. So I hope this was helpful. If you did great, then awesome. If not, just keep practicing. You'll do better next time. All right? So have a great day.